Hello, welcome to the industry's first ever AI Ops Summit. My name's Kieran Taylor. I lead marketing for CA Technologies' Agile Operations Business Unit, providing solutions for monitoring and advanced analytics. We got some great insights from our SVP of Products and Strategy, Sushil Kumar, and his guests, Dan from Coty and Carl Kleinert from Intellinet. As a reminder, you can join today's conversation when you tweet your comments to hashtag AIOpsSummit. You'll be included in our raffle for one of 5 Google Home devices. I'm really excited for our next session that tees up a new role that might be new for some of you, but for some companies on the West Coast, it's been in place for over a decade. I'm talking about Site Reliability Engineering, or SRE. It's what happens when you apply software engineering to IT operations problems. I'm joined by 2 leaders in this area. Todd Polino is a senior staff SRE at LinkedIn. He's tasked with keeping the largest deployment of Apache, Kafka, Zookeeper, and Samza fed and watered, whatever that means. We'll find out. Todd is also a co-author of O'Reilly's Definitive Guide to Kafka. He's responsible for architecture, day-to-day operations, tools development, including the creation of advanced monitoring and notification systems at LinkedIn. We're also lucky to have David Blank-Edelman. David is a SREcon co-founder and author of O'Reilly's forthcoming book, Seeking SRE, Conversations About Running Production Systems at Scale. When does that come out, David?
It'll be coming out in August if all goes well.
Okay. We'll look forward to seeing that. I'm sure it's going to be...
So very soon.
Very, very soon. Well, let's start just by asking each of you how you define the role of SRE. I'm sure you get asked that question a lot, probably barbecues and stuff like that. What is SRE? We'll start with you, Todd.
I've gone through several iterations of how to define SRE. My favorite was, I drink and I know things, which is also I drink because I know things.
That's Game of Thrones, right?
Yes, it is.
Okay.
But lately what I say is that our job is to automate all the easy things and to make the hard things easy. It's the best way I can find to distill it down right now.
Automate all the easy things and make the hard things easy. All right. How about you, David? How would you define SRE?
So I have a slightly different take on it, but which is inclusive of what Todd said. But what I usually say when people ask me what SRE is I usually say it's an engineering discipline which is designed to allow an organization to run its systems, services, products, whatever you'd like, at the proper level of reliability. Because reliability as a primary part of what you do is key, because you can have features. Your product can walk the dog. You can get your dry cleaning. But if you put all this time and energy into putting features into your product and it's not up and people can't use it, it does no good. Not only for the people that are writing these features, but also for the business. The business gets no value out of it. I also say sometimes that SRE is a way of engineering failure out of your systems. Again, the goal here is to bring your systems to the correct level of reliability, because it's not the case that most people's systems have to be 100% reliable. The thing that's beating in your chest, or maybe the thing that's flying those planes in the air, they have to be 100% reliable. But most of our systems, we recognize that there's potential for downtime and maintenance. And the question is, what can you do with that? What can you do with the knowledge and the understanding that reliability is both core, and if it's not 100%, what can we do with the space in between 100% and what you need? And that often turns into features and development and stuff like that. It's a way of having the people who are developing the software and the people who are operating the software have a nice common place to meet about what's important to them, and to be able to quantify it and use data to be able to talk about it in a way that is that makes things go together versus the usual sort of split off.
Sure, that makes sense. When we look at that middle word, reliability, so there's uptime, right? It's reliable, it's up, but sometimes slow is the new down.
Oh yeah,
right?
For sure.
Todd, talk to me a little bit about the importance of, I guess, end user experience.
Yeah, I'm fortunate to work with a development team that has reliability as a core concept. I don't have to teach them about how things need to be reliable. But yeah, the slowness when it comes, so I run data infrastructure. Kafka is data infrastructure. My clients are all internal. So I don't have an external member to deal with, but I do have internal customers, and they're all very interested in both availability of the system and the latency of the requests. So part of what we do is define what are our SLOs, what are our objectives for how slow can requests be. And if they drop below that, if we start having really slow requests, then we have to back off. We have to roll back whatever the last feature set was, and then move forwards again from there, figuring out what the problem is. We spend a lot of time going forwards, taking 2 steps forward and then 1 step back, and then 2 steps forward again as we roll these things out. And we've seen that in great detail this year as we've been finishing up work on GDPR and trying to roll out very rapid changes to get all of our security into a place where it needed to be. But yeah, at the end of the day, it really is all about, did the request, was the system up? 4 nines I'm working with right now, which some people think is insane for what we're working with, but that's what it is. And then our latency targets, and did we hit them? And that's our daily review, that's our weekly review with the entire team, both dev and ops.
It's often another way to boil it down is also it's about user expectations.
Yeah.
So availability is a user expectation, latency is a user expectation, but also things like privacy is also a user expectation. Like if you violate your reliability when it comes to privacy, that's a big problem for your business. Or let's say your Dropbox. It's not availability is super important, but so is durability. Like if I'm not giving you the bits you gave me back, then that's a big problem. So there's lots of ways to look at reliability. But it all boils down to what are the people that you're serving, be it external customers or internal customers, what do they expect? And are you meeting those expectations?
Yeah, it's not always about just reliability, as you said. It is completely about expectations, and that's part of our job as SRE, is to make sure that the expectations are hit constantly, that you can roll out new features, but if you violate the expectations that we have in place, then you need to step back and fix whatever you did. That's why a lot of teams use a concept like error budgets to say, okay, you can have this many errors in your system, and for your next deployment, you can make a choice. If you're at 90% of your error budget, you can either roll out your new feature and roll the dice that it's not going to blow past your error budget, or you can fix whatever's causing you to be at 90%, get you down to 40%, and then roll out your next feature on the next round.
Who defines what an error is? Right?
So that's a collaboration between the SREs and the developers. It's not SREs saying, you have 1,000 errors per day. That's all you get. It's me sitting down with the development team and finding out what's reasonable. So if 4 nines is our reasonable amount of availability, then if we're at 99.98 for a given day, we have a problem, we have to address it. But as long as we're above that, I don't care. You can do whatever you want. Same thing with latency. So if we turn around and say, as a team together, okay, we're going to commit to no more than 1 QPS, 1 query per second of errors out of 1,000 QPS. That's what the goal is. We codify that in the systems, and we run the systems that check it and enforce it, but we're not enforcing rules that we set up arbitrarily.
Yeah. Right, there was that initial discussion of sitting down with the developers. I mean, when you do the first question you ask is, what does up mean to you? Right, because the people that are producing the software are the ones that have the best understanding of what up means to them. Does up mean passing this much traffic? Does it mean I can reach it on the other end of a web browser? Does it mean, is it slow? Does it mean, lots of ways to look at it. And it's that gap in between that expectation. Like, I expect it to be up this much, and if you happen to have exceeded the expectation, awesome. Now we have some room to play, right? And so it means that if you were going to perturb the system, I'm going to take it to even different rounder numbers to say out of the 9s, because those always mess with me to a certain extent. Let's say you agree that my system should be up 80% of the time, and that's the deal that you're going to agree with. So now you have 20%. If I go back and I say, hey, it's been up 90%, well, great. Now I have extra room to perturb the system because I know I'm still not going to drop it below 80%. If my system has been up for whatever value of up means for 60%, then there's a hard conversation that has to be had that says, well, what's going on here? Why aren't we making the goals that you helped us set? And that may mean changing what you do at that moment in terms of where your engineering focus is. It may mean slowing down your release cycle. It may mean lots of things. And SREs are just there to help facilitate this conversation. They're not meant to be the ones holding a stick over you going, your thing has been down and you are terrible people and you should feel horrible about yourself. They're there to help facilitate the conversation of, this is what you want. Our job is to help you get what you want. You haven't already. We have the data that shows us that we all agree on, so now what do we do? And that's, I think, a key role of SRE.
So we're here at an AI Ops, Artificial Intelligence for IT Ops.
Let's talk about that.
Summit. What role do AI and ML play in the life of an SRE? I'll start with Todd and then go to David.
Yeah, those are great terms. I hate both of them,
You do?
AI and ML,
Okay.
because nobody really knows what they mean, and everyone thinks that it's just some little magic you throw into your system and it makes everything great. It really does come down to, I prefer to say to use the term advanced algorithms, because some of the algorithms we use for detecting problems, for example, are just pure thresholds. If you go above 100 errors per second, that's an alert and we're going to call you. Sometimes it's a regression. So we have some calculation that we're doing to target, okay, based on the number of requests, these are the number of errors we're going to tolerate. Machine learning is just another set of algorithms that we can throw in there, and you still have to pick the right ones for what you're doing.
You have to understand your data.
Yeah, you have to understand your data. And you also have to understand that the decisions that I make for my application will probably not work for David and the decisions he makes for his application. There's going to end up being two different algorithms that are in place.
Yep.
So it's not a simple thing, but it's also something that many of us have been doing for years and years already. The more sophisticated SRE organizations are already doing automation in response to problems. I mean, we hear this from LinkedIn, we hear this from Facebook, from Google. Everyone's talking about, how they automate responses. And we're starting now to apply some of the more sciencey parts of data science to our operations and figure out how we can make it even better. Because our systems are only getting larger and we're not getting more people to run them.
Yeah. David, I saw you nodding.
I'm in total agreement with Todd. I guess my only additions would be simply the case that if we make the assertion that SRE is a space that's data-based and that we are running systems of ever-increasing complexity and ever-increasing size, and SRE is for sure about scale, then we can use all the help that we can get. And one of the helps that we can get is through the application of advanced algorithms. I agree with Todd's thing, just because I think that Todd and I have been through enough phases and hot buzzwords to know like there's got to be something there. But luckily there is something there on AIOps. It's just another way of describing this thing that says, look, I've got a lot of data, or I'm generating data, or I'm trying to figure out what my data is, and maybe, just maybe, if I were to do the right processing of this data, I would get some information out of it that would be useful for me to figure out how to provision what I'm going to do next, how to save money, how to figure out like when something has gone wrong. Have I ever seen this before?
Right.
Will I see it again? Is there anything? Is the anomaly that I'm seeing right now something that I should worry about, or is it just the World Cup is on right now, and therefore the traffic has tanked really hard for that period of time, which is something that Google encountered, where they had an all hands on emergency alert at one point in time because it looked like one of their entire regions had stopped taking as much traffic by a significant drop. And when they were figured out later on and they did the postmortem, they're like, oh right, it was the World Cup. People weren't paying attention to their computers.
Right.
So but the question is it possible, when given all this data, to know, should I worry at this point? Should I wake somebody up? Or if I've woken somebody up, what can I tell them to help them get to a resolution faster? Do I have the right people in the room? There's lots of questions that you can ask if you were just paying attention to the data that we're collecting and instrumenting our systems to collect.
Yeah, and a big part of this, actually, you were talking about the questions there at the end. A big part of this is figuring out what questions should we be asking about our data, and what questions can we actually reasonably ask about our data. Right. Like LinkedIn generates over 50 terabytes a day of unique application metrics. This is measurements on the applications, tracing data, log files, well over 50 terabytes a day of useful data. I find it hard to believe that there aren't more interesting things that we can do with that data, even if it's just identifying how much of it is completely useless to our day-to-day monitoring
Right.
and debugging. Like what's never...
What do I throw out?
Yeah, what's never looked at, what doesn't correlate ever with an error. And if we can get rid of that, I mean, that saves my headaches a lot, because I'm the one who has to take all that data.
So once you understand your data, you said earlier, it's all about automating the easy things. Give me an example. What's an easy thing? You know?
So a good easy thing is capacity planning, or it should be easy for a lot of people. Most people don't do it as much as they should. But for like a web application, for example, you've got a few metrics that you have to look at for most of them. You have the number of calls you get per second or per minute or however you're going to measure it. You have the number of errors that you have out of that number of calls, and then you have the latency for your requests. And those are three simple metrics that you can take and feed into a reasonable model. Of course, you have to come up with the model and project that out long term. So you can say, okay, I have a year's worth of data now on how this application's been performing. And if I take that year, I can project out what's going to happen over the next year with some degree of certainty. And I can know that in the next quarter, I need to buy 10 more servers. And the quarter after that, I need 50 more servers because of the way the traffic patterns work. And then get an idea of how much you have to buy in advance so that you're not trying to do it at the last minute constantly.
Sure. What's an easy thing for you?
Well, I was going to just build on what Todd said. The other thing you can do is sort of correlations, right? Because the other thing in addition to these things is what does the incoming traffic look like? And so if you could do something along the lines of saying, oh, I know what my incoming traffic looked like and I know how well I served it based on that sort of stuff, you can decide whether it's time to spin up more instances in your cloud provider. You can decide, because that's money, right? Every time you push the more please button, that's more money. You can know, well, oh, I see. Well, it looks like on Fridays during the summer, we don't really nearly have as much traffic coming to us, so we can reduce our spend on stuff like that. So, to my mind, like when we say this is easy, we don't mean it's trivial and it's a solved problem per se. We just say that like the variables are pretty well known. The ability to figure out how to calculate this stuff is pretty well known. I think that's what I think of when I think of easy versus the like, wouldn't it be nice if we could figure out if the computers are doing the right thing, which is like a very vague statement. In theory, it can be helped with AI ops or stuff like that, but you really for sure have to figure out what as Todd said, you got to figure out what the problem is before you can start on the answer. So I think that the easy stuff around that is out there. I think we can also start to do more easy stuff around, have I seen this stuff before? Have these machines failed the same way in the past year, in the exact same way? Have we seen this failure before? When you start to look at stuff, and if you can get that information, it can really slow, speed up the time to ameliorate these things, or to just make sure, like, oh, I see. So we have a problem with memory leaks. Let's spend some time in this particular cycle of our engineering talent to look for memory leaks.
Right.
Congratulations, like you have improved your system immeasurably going forward.
Right. Are you guys doing things like Donovan from US Bank mentioned, this concept of pattern recognition to detect a problem, and then almost having a library of remediation options and in a chaos monkey sort of way, testing them to see, hey, which remediation actually works best? Anything like that happening? I'll start with Todd, then go to David.
Yeah, I mean, we're starting to collect that data. A lot of it is that we don't have a lot of good data about what happened last time. So we have data about the system, and we can go back and look at the metrics, but we don't necessarily right now collect the information from the response. So, who worked on the problem, what did they try, and what eventually fixed the problem to know. Now, what we do is we have automation, for example, for restarting applications that have died. And we review those numbers weekly as far as how many restarts are there. Because while the automation is doing what we want it to, and it's solving the problem of not waking me up in the middle of the night to restart an application, if I suddenly start restarting the application 100 times a day when yesterday it was only restarting once, okay, and now suddenly I have a problem. What I don't want to do is I don't want to try to add automation around every single possible use case and monitoring around every single possible problem that I could see in the system. I just want to know from the automation or from from my advanced part of it, what's wrong. Like, something is wrong here. I can dig in as a human and find out exactly what's wrong. And if I track that information, how I found out exactly what was wrong this time, and oh, it's a memory leak, and then next time, oh, it's a memory leak, well, we start to develop a pattern there, and then we can identify at least, okay, what were the last 50 problems we saw? Okay, 30% of them were memory leaks. Well, let's put 30% of our time on fixing that.
Yeah.
I mean, it can be tricky because typically people are busy enough such that if they've fixed a problem, they're not immediately inclined to spend a lot of time. They're on to the next problem, I guess is the easiest way to say that. So gathering the data as to what the remediation was can often be a little tricky. I'd like to address the sort of chaos monkey thing, just because I think it would be useful. Because chaos engineering is one of those things showing up in SRE land as well. But and I think that chaos monkey was sort of like chaos engineering 101. It was the initial steps into that. It's gone very farther, and it's a discipline in itself that's about experimentation to try to determine how your system behaves in production. And what I guess I want to say is that let's just stick with Chaos Monkey. Chaos Monkey is as much a tool as helping your engineering processes as it is about your operational practices. Like the thing is you're not running Chaos Monkey, like if something is already out there and out in the world and you're using it to test it, the goal for that sort of testing is to go back to the way you're building your software, the way you're constructing your software to make sure that it can handle and has the resilience built into it. Mm-hmm. So to my mind, it's as much a development process as it is an operational process. Like it's maybe useful to know that if I shoot things randomly in operations, things are bad, but that's not the answer you're shooting for. You're trying to find out in production, in the world that you cannot anticipate, how will things fail, and can we push the lessons that we learned about how things can fail in the real world back into operations such that we're building software that is resilient. And the people that do it, that started this, the people that wrote Chaos Monkey to start with, Netflix, my understanding is, and I think this is still true, that when you create a new service at Netflix, unless you turn it off automatically, Chaos Monkey is turned on for that. It will randomly shoot your new service as a start, right? It isn't one of these things that they added later. It's just like the fact that you run through CI/CD to test your stuff. Also, we're going to see what happens when things randomly die on you. And so that works because Netflix has a really good engineering culture around building stuff that is resilient from the start. And so if you can use the chaos engineering as a way of improving your culture to build things that are resilient from the start, that's going to help you a great deal. By the time it gets to operations and gets into production, you're thinking about it way too late. So you have to pay attention to it earlier in the cycle.
So building on that concept, Todd, how are SREs connecting back earlier in CI/CD, talking to development, shifting left, so to speak?
Sure. I mean, I'm an embedded SRE. So my team sits with the Kafka development team at LinkedIn. We plan work together. We prioritize, quarterly goals together. So we function as a single team. One half of that team is development, and one half of that team is SRE, operations. But we're all working together towards the same goals. We want the system to be resilient. And as David was saying, with chaos engineering, the goal is identify how your application fails. Because your application is going to fail. Disks will fail, memory will fail, CPU will fail, there'll be network partitions, there's going to be all kinds of problems that you're going to run into. And if you know how your application responds to that, then from a development point of view, you can take that into account and say, okay, I know that this is a possibility of something that's going to happen. Mm-hmm. I can make this change to the architecture and it will make it better. It won't make the problem go away, but it'll at least make it better so that we can tolerate it. Which then on my side makes it much easier for me, because now when the application fails in that way, I don't have to worry about it as much. The system is engineered to be more resilient. But that's all a result of a constant loop back between SRE and development.
Sure.
If I don't make it painful for development, when there are problems in production, they won't fix the problems, because you have to have the pain to drive the priorities. Yeah. So that's why we have those constant meetings where we say, okay, these are the 5 things that are causing problems for us right now. Like, this is the one alert that we're seeing that's going off constantly and we ignore. So let's figure out why it's going off and fix that problem so it doesn't go off anymore.
I was going to say that to a certain extent, SREs are also resources about how things behave in production and reliability. Just like when you have a security person who works with your team, that person isn't the one who's responsible for all the security of all your software. You don't go, he or she over there, they do security. So reliability is a responsibility of sort of everybody in the org. What you have with an SRE is somebody who has chosen to focus their career and their attention on the things that make things more reliable, the way to understand how to provision envision things, the way to understand how to build stuff, what sort of architectures are going to work for you. What we've learned in the past, often they can be institutional memory. Like, yeah, we built it that way once over there. Didn't work so hot for them. I'm just going to let you know. So I think that ultimately there's an E on the end of SRE, right? Engineers, right? So we're all engineers in this boat, and so I think that's crucial that there's a working together.
Yeah, and over time, you're going to naturally see the team come together. We're all engineers, as you noted. It's just the software engineers are coders primarily, and they're focusing on features and the architecture of the application.
Right.
And SREs are also developers, but we're focusing more on the operations piece, and that's the expertise we bring. Over time, as your team interoperates more and has this constant loop, you find that the software engineers and the SREs kind of become the same person.
Right.
The more reliable your application is, the less time the SREs have to spend putting out fires, which means the more time they can spend on development pieces and getting to know the internals of the system.
And in some orgs, it's exactly the same staffing pool.
Yep.
Like you can swap between SRE and SWE, which would be the way that they discuss the software and the people that write the software back and forth. Exact same staffing pool, exact same sort of thing, and people flop back and forth. And it's just it's sort of like I'm interested in doing this. Like some people are inclined towards paying attention to that, just like they're inclined towards paying attention to security. So they might be doing the security part of your operations, but they could switch over to doing anything else. So I think that mushing together is good.
Yep.
Yeah. We have 60 seconds left. Quick question.
Yeah.
Quick question. You guys have been doing this for a while. You mentioned Facebook, LinkedIn, Microsoft, really big companies. What about smaller enterprises? Are you starting to see SRE making inroads there? Regular companies?
So I can speak to that. Yeah, for sure they are. My experience is that if they're not splitting up entire groups, they're taking in SRE principles and they're starting to experiment with things like error budgets and that sort of stuff, or making their organization be service level objective based as a way of having communication within it. So it for sure is getting the uptake is surprising to me, and I think it's got a lot of potential for organizations of any size.
Yep, absolutely agree.
All right. Good. Well, we could talk easily for another hour.
For sure.
As a reminder, we do continue the conversation on Twitter. Just hashtag AIOps Summit in your tweets, and you'll be included in a raffle for one of 5 Google Home speakers. If you're working with any aspect of web scale applications, you're probably leveraging containerized apps. Our next section is a deep dive into how IT teams deploy, monitor, and manage those apps. It features Paul Maddox of Barclays and Scott McCarty of Red Hat. They'll be up in just 2 minutes. Please stay tuned and join us for that discussion. Join me in thanking Todd, and thank you, David, very much for your time. It was a great session.
Karen.
Appreciate it.
Totally. Yeah. Thanks very much.